It's early Sunday morning, so I'm a little tired, but let's go ahead and get this started, all right? So, one of the main things that we want to be able to do is we want to use the quadratic formula with logarithms. And I'm going to give you a problem here that should help us to just kind of get started. Let's do log base 2 of x plus 4 is equal to 3. All right, so we need to solve this problem. We want to find the x value that when we plug it in, right, log base 2 of whatever this input in here is, it's going to give me 3. Now, in order to be able to do this kind of problems, right, there's a couple things that we'll need, right? For this one, we're definitely going to need to be able to convert from logarithmic to exponential, all right? For the ones that involve the quadratic formula, which we're going to get to, it's going to require the product rule for logarithms. And finally, just remember that it's not possible for us to have log of 0 or log of a negative number, right? These things are impossible to compute. And if you're curious, again, as to why, we'll just convert these back into exponential form, and I think you'll see why it's not possible. All right, so how do we go about solving this problem? Well, we need to change this back into exponential form. And if you're confused, you can always go back to ILF2 on the categories, and that's going to help guide you. All right, so how do we convert this? Well, our base is 2, so we're going to get 2, right? Well, my input, remember, logarithmic and exponential functions are inverses of each other. So if this is my input, well, that's going to become my output. And if this is my output, that's now going to become my input, right? These are inverses of each other, so our x and y's flip. All right, now that we've done that, well, what's 2 times 2 times 2? Well, that's 8. So we're going to get 8 is equal to x plus 4. And now we just solve, right? Now that's great because we turn it to exponential form and we can solve for it. Well, we subtract 4 to both sides and we get x is equal to 4. And that's my final answer, right? So now the big question is, well, what happens if I plug 4 back into my equation, right? Well, if I plug 4 back into my equation, I'm going to get log base 2, 4 plus 4. Well, that's log base 2 of 8. And that's great, right? This 8 is a positive number. It's not 0 or negative, right? If we got a 0 or negative number, we would have to cancel out our solution, but that doesn't happen, so we're good. Now, if you wanted to, right, let's just set this equal to x. Now you can actually see why this makes sense, right? Well, this is my base 2, right? Well, my output is now going to become my input. So 2 to the x is equal to, and my input is going to become my output. And so now basically this problem saying is, well, 2 raised to what power gives me 8? Well, that means x has to be 3, right? And that's exactly what we wanted, right? We wanted the whole thing to equal 3. All right, let's go ahead and look at something a little more challenging. Let's say we got log base 3. We'll do x plus log base 3 of 2x minus 1 is equal to 2. Okay, so to solve a problem like this, right, this is where I was saying that we need the product property for logarithms, right? Well, we have this input and these inputs here, all right, x, and then we have 2x minus 1. Well, remember, since it's a plus sign here, our inputs are going to multiply. So we're going to get log base 3, okay, x times 2x minus 1 is equal to 2. Okay. Now we just distribute it out inside. If you want to, you could do that right now. And we're going to get log base 3 of, well, x times 2x is going to give me 2x squared. And x times negative 1 is going to give me minus x here. And this is all equal to 2. All right. Well, now let's go ahead and convert this, right? This is like the other problem that we just had. Well, this is my base 3. My output is going to become my input. So I'm going to get 3 squared equals, and now my input becomes my output. 2x squared minus x. All right. Well, this is going to give me 9. So I'm going to get 9 is equal to 2x squared minus x, right? Because that's 3 squared gives me the 9. Now we just subtract 9 on both sides. And we're going to get 0 equals, and we're going to get 0 equals, because this cancels, 2x squared minus x minus 9. All right, now what we have to do is, well, now that we got this expression here, now we just use the quadratic formula and solve for this problem here, right? Well, my a value is 2. My b value is -1, right? 2, -1. And my c value is -9, okay? So if you have the quadratic formula, you can go ahead and plug it in. I already know it by memory, so we're going to get negative. I'm going to put the parentheses, right? Plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, okay? This is, the b goes in here. Well, my b is -1, so -1, -1. All right, my a value here is 2, and my c value is -9, okay? And here my a value is 2 again. So we're going to get x is equal to, well, what's going to happen with the negative and the negative? Yeah, they're going to cancel, and you're going to get a positive, plus or minus. 1 plus or minus the square root. And like before, I'll go ahead and open up my graphing calculator here. Okay, open that up, and I'll just go ahead and do this whole thing there, right? Let's go ahead and do -1 squared minus 4. I'm just doing the part inside the radical, times 2 times -9. All right, what do I get? 73. So I know in here I'm going to get 73, all divided by 4. This is going to equal 1 plus or minus. Now I'll go ahead and do it. Square root of 73. Right? What's under the square root? Let's go ahead and get that. It's going to be, okay, 8.54. I'll go ahead and say 8.54. So 8.54 all divided by 4. Okay? Now I'll just break it up into two equations, right? We're going to get 1 plus 8. Was it 8.4? It was 5.4. What was I thinking over here? This should be a 5.4. Okay? 8.54 all divided by 4. And over here we're going to get 1 minus 8.54 all divided by 4. Right? And this is going to equal. So let's just go ahead and solve this and do this, right? We're going to get 1 plus 8.54 all divided by 4, which is 2.38. 2.38. All right, and then we're going to go ahead and do the next one, which is going to be 1 minus 8.54 all divided by 4, which gives me negative 1.885. Negative 1.88. All right. So now I know, all right, we're doing a lot of work here. X is equal to 2.38 and x is equal to negative 1.88. All right, but we have to be careful because remember, I told you in the very beginning that we cannot have log of 0 or log of a negative number, right? So we have to go back to our original problem, the original problem we started with, which was this, and we need to plug them in and see if we get 0 or a negative number. So I'll write it over here, log base 3 of x plus log base 3 of 2x minus 1 is equal to 3, okay? Well, if I take the negative 1.8 and plug it in here, and take it and plug it in here, right? Do I get a negative number in any one of them? It doesn't matter whether one of them comes out negative or 0 or positive. It's just one. If one of them comes out negative, then, well, it's not going to work, right? So if we take this and plug it in here, we're going to get log base 3 of negative 1.88, right? And I don't even need to continue because I know this is not possible. We cannot have a negative number in there. All right, so since we cannot have a negative number in there, I know that this solution is not going to work. Okay, well, let's go ahead and try this one out. If I plug this into here, I'm going to get log base 3 of 2.38. And this is good because it's positive, right? The 2.38 in here gives me a positive number. All right, now I go ahead and take it and plug it into here and see if it satisfies this one. Well, log base 3 of 2 times 2.38 minus 1. Well, for sure this is going to be like greater than 4, right? 2 times 2 is 4, so 2 times 2.38 is going to give me 4 something, right? So let's just say like this is 4 minus 1. And obviously this is going to give me a positive number, right? It's going to give me a positive number in here, and I'm good as long as I get that. So since I can plug this number into both of them back into my equation and get a positive number, then I know for a fact that this is my final answer. All right, thank you. I hope that helps out. Take care.